All right, guys, open your SABs somewhere around page 237. This is one I'm going to jump right into because you'll be able to tell soon, but this is a 4-page lesson, and I'm going to try to do it all in one day. Don't let that overwhelm you, because that just means that I'm going to skip quite a few problems, and then you can choose that as one of your options to go back to show some of your work today, okay? So this is all about equivalent fractions, which you actually have a little brief knowledge of. We did it pretty early while we were still in the classroom, which now seems long time ago, okay? So we're going to start first with just some visuals to help you out. So this says equivalent fractions, read and discuss the problem situation. So Luis works summers at Maria's fruit farm. One day Maria agreed to give Luis extra pay if he could sell 2/3 of her supply of peaches. They started with 12 bags of peaches and Luis sold 8 of them. Luis said to Maria, 8 bags is 8/12 of the 12 bags you wanted to sell. I think 2/3 is the same as 8/12. I can show you why. And Luis made this drawing. Did he earn his pay? So Luis is doing a great job of comparing two perfectly sized shares. We talked about that yesterday, that each of your shares, when you're comparing fractions, it's okay if they have a different denominator as long as they have, they're the same size. So here I have 2 bars that are exactly the same size. The one on the top is cut into 3 equal pieces, and the one on the bottom is cut into 12 equal pieces. And here's what this is showing us. This is showing us the 2/3 shaded in green, and then the Luis showed us his 8/12 that was shaded in green also. So that shows us that this 1/3 and this 8/12 really truly are the exact same fraction. You can do it like thinking of a pizza, right? So if I had 1/3 of a piece of pizza, that would be this much right here. Why did I choose thirds? But that's okay. And so then if I were to successfully cut this pizza into 12ths, oh gosh. Well, you know, you get the idea. And then I were to do 4 of them, you can see that those two match up pretty well, okay? But these fraction bars do a much better job of showing you that. So let's also jump into what this same problem says with Maria, and I believe it's still, is that the same people? Sorry, guys. Oh, yeah, okay. So this is still Maria's fruit farm. My fault. So this says 2 fractions that represent the same part of a whole are called equivalent fractions. And that's really just thinking about an equal sign right between the 2 of them. And she's telling you that 2/3 is indeed equivalent to 8/12. Okay? So it says, Maria said, you are just fracturing each third into 4/12. You can show what you did using numbers. And here's what Maria wrote. So Maria said that 2/3 is if you took 2 times 4 to equal 8, and then 3 times 4 to equal 12. So here's what I want you to notice. This is the number one most important thing about equivalent fractions. Whatever you do in a fraction, as long as you do it to both the top and the bottom, it doesn't matter. It's going to be the exact same thing, okay? So if I gave, one student 1/3 of a candy bar, and I gave another student 2/6 of the exact same candy bar, they're getting the exact same amount. It doesn't matter what the fraction is, because I could go from 1/3 to 2/6. Well, how would I get from 1 to 2? I would times that by 2. So how do I get from 3 to 6? I also multiplied that by 2. So I then can tell that those are totally equivalent fractions. So what do I want you to write on this line? It says, discuss what Maria did. How does multiplying the numerator and denominator by 4 affect the fraction? And I want you to basically say that it makes it the same. It says multiplying, we can do an X symbol for that, multiplying both by 4 makes an equivalent fraction and we'll leave it just at that, okay? So it makes it basically an equivalent fraction. They're going to be the exact same thing. So let's look over here at this bar right here, and this is nicely already laid out for you. And again, if you'll remember, we had a really big colorful chart. This is the one we played around with one day in class, where we talked all sorts about equivalent fractions here. So this is just another reminder of that. So I'm going to draw a big old line down here. Okay, and what this is going to show us is exactly what that gray bar already does. If I'm talking about finding equivalent fractions for 1/3, this is going to show me that answer. This is going to tell me that 1/3 is the same as 2/6. It's going to show me that 1/3 is the same as 3/9. it's going to show me that 1/3 is the same as 4/12. I should probably separate these a little bit. It's going to show me that 1/3 is the same as 5/15. And then it's also going to show me that 1/3 is the same as 6/18. So take a second and look to see what you notice. What do you notice about your numerator and your denominator in each of these problems? I think you're going to start to notice a pattern, and I'm going to circle them to kind of show you what I'm talking about there. So what do you notice about those numbers that I circled in red? And then what do you notice about these numbers that I circled in green? Think about that for just a sec. So here's what I notice. 2 to 3 to 4 to 5 to 6, those are all getting just one bigger, right? But then from 6 to 9 to 12 to 15 to 18, those are all getting 3 bigger, right? Well, what was the original fraction that I started with? It was 1/3. So you'll notice that each one is growing the same amount. The top numbers are growing by 1, and the bottom numbers are growing by 3. Okay, that's exactly the way that it should be if 1/3 was your fraction. So now I want to show you this page because it's going to kind of spell out to you the easiest way to find an equivalent fraction. So it says you can show how to find fractions equivalent to 1/3 numerically, which just means with numbers. It says fill in the blanks and finish the equations, then explain how these fraction equations show equivalent. So it's kind of what we already talked about. So here's the first one that they showed you. If I wanted to make it 2 parts bigger or 2 times bigger, that's just going to be 1 times 2 is 2, and 3 times 2 is 6. And once again, you're going to notice they're multiplying the top and the bottom by the same number. So this time, if I want to make it 3 times bigger, I'm going to multiply the top by 3 and the bottom by 3. You should be writing that with me. And that would be 1 times 3 is 3. So that shows me that 1/3, is the same as 3/9. So then we have 4 equal parts. That means I'm going to make it 4 times bigger. So I'm going to do the same to the top and the bottom, which is to multiply by 4. 1 times 4 is 4, and 3 times 4 was 12. Is that making sense? Are you seeing what's going on here? If I wanted to make this 5 equal parts bigger, I would multiply it by 5. So 1 times 5 is 5, and 3 times 5 is 15. So then that makes the last one easy. That's going to be 6 equal parts bigger. I'm going to multiply that by 6. 1 times 6 is 6, and 3 times 6 is 18. Okay? You can literally make an exponential amount of equivalent fractions. What that means is there are infinity numbers on this planet. Numbers go on forever, and that will be true for your equivalent fractions. I could choose to make 1/3 be something insane by like multiplying both the top and the bottom by 257, right? And it would get 257 times bigger. And I don't actually know what 257 is off the top of my head, but that's the number that would go there. And no matter what, it would still be 1/3 in size. It's still going to be the same. It doesn't change it. Even though it's much bigger numbers, it's still just 1/3 of your original. Okay? Okay, let me erase some of that because I got off on a tangent. What's new? And I want to help you see these ones right here. So it wants you to tell whether these fractions are equivalent. So this one, the way that I like to look at it is if I'm trying to get to 1/6, it wants me to get to 2/12. So how would I get from 1 to 2? I would times that by 2. And how would I get from 6 to 12? I would times that by 2. So because these are both being multiplied by 2, yes, these are indeed equivalent. Okay? Let's look at 3/6. So 3/6 and 5/9. Well, I can already tell that this one's a no because how do I get from 3 to 5? I have to add 2, and no parts of finding equivalent fractions have anything to do with addition. So because of that, I already know that that answer is no. And then let's look at 6/12, and then also 8/15. Okay, this one's a little trickier because I think I could actually make these fractions smaller, which is not quite what we're talking about today. So instead, I'm just going to focus on the fact that you can't do anything times 6 to equal 8. And because of that, then that means that this will also not be an equivalent fraction. All right. Oh gosh, I am pretty far behind on my time, so I'm going to skip a few for the rest of these, but I want to show you this awesome multiplication chart that they have for you and how they're helping you use it. So this says you can find fractions equivalent to 1/3 by using the products in the rows. So if this was your row of 1, and then it's your row of 3, they're telling you that if you move along this line, this is gonna be the change in your denominator, and this would be the change in your numerator. For example, watch me move over 1 place. That's going to be a 2 in my numerator, and what number is going to be in my denominator? That's a 6. If I move over 1 place, that's going to be a 3, and then what's going to be my denominator? That's a 9. If I move over 1, 2, 3 places, actually let's do, well that's fine, 3 places, that would have been a 6 as my numerator, and if I moved over 1, 2, 3 places, that would have been an 18 as my denominator. So you see how they're equal parts apart, or equal numbers apart from each other. If I were to go 2 more places over, that would give me an 8 as my numerator. And if I were to go 2 more places over here, that would be a 24 as my denominator. All of these right here are equal to 1/3. They all mean the same thing. Okay. This is one that I'm going to do a couple of them with you. I really want you to do the rest on your own. I think this would be a good practice for you today. So complete each fraction multiplier. Here's what you're asking yourself. How do I get from 1 to 4? That's going to be times 4. So how do I get from 3 to 12? Also times 4. Come down here to number 11. How do I get from 5 to 30? That's going to be times 6. So how do I get from 8 to 48? Also times 6. Okay, so then let's look at one. This is asking you the same thing as before. Tell whether the fractions are equivalent. All you want to ask yourself is how do I get from 3/4 to 12/16? And if I end up multiplying by the same number on the top and the bottom, then that means that they're equivalent. But one like on B, 1/2 equals 5/12. How do I get from 1 to 5? Well, I would times that by 5. But how do I get from 2 to 12? I would times that by 6. So because those are not the same, that's not an equivalent fraction. Okay? I apologize for bouncing around a little bit, but these are ones you're going to go back and do on your own. I want you to notice that I do not need you to do the puzzled penguin problem. It's okay. But then the rest of this page is one that I want you to do. So it says find a fraction equivalent to the given fraction. They're just wanting you to create some. This is the easiest one in the book. You're just going to choose any number that you want and multiply both the top and the bottom by it. So let's just say on number 16, I'm going to choose 6. So if I wanted to make this 6 times bigger, I'm going to multiply both the top and the bottom by 6. So what's 3 times 6? 18. And what's 10 times 6? That would be 60. So that shows me right there an equivalent fraction. The easiest ones to multiply are by 2 and then also by 10. Those are the easy way outs. It's okay to do a couple of those like that. So if I did the top and the bottom of these by 10, that would be 30/40ths. It's just, that's not very good practice, okay? And then obviously you're going to try number 10 or 22 as well. That could be a tricky one, but that's one that I would like you to try. So my encouragement for you today is to actually go back and finish these SAB pages. If you need any help, you can always log into a Zoom call and I'd be happy to help you. But if you would rather not do the SABs and want to move on to homework or IXL, obviously fine with me. Just make sure you are really coming to get the help if you need it, because equivalent fractions can be kind of tricky. Okay? Best of luck. Oh, by the way, I should also mention, Khan Academy is a really wonderful website. You've heard me mention it many times before, but khanacademy.org is going to have really wonderful tutorial videos if this just didn't cut it for you. So if you were to go to khanacademy.org and you could search for equivalent fractions, that's going to be another lesson on just the same, and maybe will help you even more than mine did. Okay? So no matter what, make sure you're understanding those equivalent fractions.